which is a local privesc script. It can enumerate various common local admin privilege escalation techniques, which isn't going to run because it's blocked. But if we use this PowerShell command, which, cool, it's fairly legible, we're going to invoke expression, we're going to download the script, which, let's cut it off a bit. There we go, I found the scroll bar, neat. We've got the URL there, which is my local VM host, but obviously it could be anything else. So basically it's going to run the PowerShell straight from memory and then run the invoke all checks command, which is running. And neat, we found some creds. These might be local admin, we don't know, we'd have to check. Cool, you're paying attention, that's great. As we've seen, we can't simply solve this by blocking file extensions on the machine. It's not going to work. You need a defense in-depth approach. So if you're in an environment where you've got users that need an interpreted language like maybe Python or another interpreter, build up a policy for those users. Maybe it's data scientists, devs, sysadmins, group them all in that and allow Python or whatever your interpreter is to run just for them. As for PowerShell, there's a few modern security features for modern versions of PowerShell, which can help detect and prevent these attacks. Script block logging can be used to you can configure it to send the code that you execute within PowerShell to your SIEM, where your analysts can have a look, triage, work out whether it's malicious. You could probably even go a step further if you're really keen on working out which users really shouldn't be running PowerShell and trigger some alerts for that so you can go straight to triage. Constrained language mode blocks specific operations from running in PowerShell. And when I was playing around with the download technique here, I found that on a system with PowerShell 5.1 installed and an Applocker policy configured and script rules enforced, constrained language mode was just enabled. But I never found any good Microsoft references that explained exactly what was happening there, as to whether there was any particular variables that were needed or whether it was just a blanket rule, or even if it applied to just Applocker and Defender application control, or if third-party products like, I'm not going to mention any names, any other commercial allow list products are able to feed into that as well. So your mileage may vary. I never found any solid proof, but yeah, it's definitely something to consider. Lastly, anti-malware scan interface, or AMSI, can provide some visibility into the stuff that's happening within PowerShell to your endpoint protection you've got there, so that might be able to detect and block stuff too. All this stuff is awesome, but PowerShell 2 doesn't support any of it, which means that if you've got PowerShell 2 in your environment, you could just append version 2 to your command that you're running, and it would sail past all those defenses. So you want to block PowerShell 2 from running as well. You might be able to do that through your allow list policy, or maybe you uninstall it. Thinking back to our attacker with a standard shell again, we were able to download the PowerShell that we wanted to bypass the allow list, which as we just sort of talked about, it needs constrained language mode to be disabled when you do that, or you need to have PowerShell version 2 enabled as well. So it might not be as effective as some of the other methods, but it really depends on the environment you're trying to use it in. And with PowerUp, which was the example we used, we're able to look for local privesc techniques. And look for any bugs that might let us get local admin. But one of the other kind of neat things that you might be able to use this for is to automate enumerating the Applocker policy and then poke at random the file path rules that come out of it, so to really quickly give you the quick win that opens up that first file path use case we had, where you can just then run anything you want. So kind of upgrading your attack from PowerShell to anything. So where to from here? For those of you that are lucky enough to have allow listing enabled in your environment, think back over all the weaknesses we've seen today. Think back about if there's anything that maybe you could improve. If there's anything you go, oh, I really want to look at that before Monday, maybe do that. And if you haven't already, look into the Microsoft recommended block rules to prevent your lull bin attacks. This is going to require you to plan out how you're going to audit, monitor, tweak as required, because you're probably running some of this stuff and then ultimately execute it to block those lol bins from running. And for those of you that don't have an allow list in your environment, or maybe you don't have an environment, I'm going to be publishing this Applocker policy we're using today on GitHub in, I guess, 20 minutes. Have a play around with it. It was designed for this talk, so it does have those vulnerabilities we've seen in it, but it's probably got some others too, so just don't go yeeting it into production. I don't know why you would, but just don't. If you're wanting to use it, I'm going to have to suggest that you use a Windows VM that's Windows Server. Windows Workstation OS, the enterprise licensing is needed for Applocker to work. And when I say that, I played around with this as part of this demo to have a look. It happily imports the policy, it applies the policy, you can start the app ID service, it just fails open. It's so dumb. But the last thing I'll say is that if you do think you're breaking something, there's a allow rule for any admin stuff. So admin can run anything. So if you really break something or something's not working as expected, log in as a local admin on your VM, clear the policy, and away you go. On that slide, there's the references. I'll probably put those couple of references in the GitHub when I publish it, but you've got the lolbaz stuff where you can look at all the different lol bins. You've got the link to the Ghost build where we created our malicious XML C# project, and you've got the Applocker policy, which will be up by the end of the day before beers. Any questions? Yes?
Why do you have a kiwi on the slides?
Sorry? Oh, the kiwi fruit is like the icon for Mimikatz, which was like one of the first attacks we used, but yeah. Cool. Thank you. Sorry?
First talk.
Thank you. I have no idea how long that went for because
miles over. No, it was really good. No, it wasn't.
Awesome.
I was going to be waving up the cardboard.
Yeah, awesome.
Right, kill that one.
Let's put it in my pocket. Thank you.
Cool. Okay, thanks Russ for that one. We are just not even taking a break. We are getting straight on to Matt Green from Rapid7 talking about Velociraptor. So that's a stream talk, so we'll just fire that one up and get it going straight away. Thank you.
Herding velociraptors. So first of all, a little bit of an introduction. My name is Matt. I work at Rapid7 on the Velociraptor project. I have a background in DFIR and detection things, and I've been using Velociraptor since the very early days. The agenda for today is I'm going to cover a little bit of background on what Velociraptor actually is. I'm going to cover off some requirements for incident response, and then introduce kind of like a demo scenario that I've created that I demo a bit and test on. And then I'm going to kind of cover off how we hit those incident response needs in a demo. The goal at the end of this will be to kind of introduce everyone to Velociraptor and then to encourage use and for people to go off and explore their own use cases and workflow. So first of all, what is Velociraptor? Velociraptor is an open source digital forensics and incident response tool. It's an endpoint tool that covers pretty much all the big use cases for DFIR. If you don't know who Mike Cohen is, he's very well known on the blue team side of the shop, but he was the lead developer in Google Rapid Response and Recall. So it has quite a good pedigree in terms of building amazing tools. Essentially, Velociraptor is seen as kind of GER 2.0 that's been built from the ground up to be very simple and solve a lot of the complexity problems that GER had. It's a single binary written in Go for both the server and the client components. And because of that, it's statically linked, and we support a very wide array of operating systems. You can see the architecture is really simple, a server-client relationship. The whole idea here is that simple architecture drives DFIR at scale, which is pretty hard to do. And we're trying to simplify both the deployment as well as execution. It's query language driven. So if you're familiar with tools like OS Query, you're going to be very familiar with the kind of syntax that we're using in Velociraptor. Velociraptor query language is kind of formatted like you can see on the screen. We essentially generate our rows of data using what we call plugins. We select columns with the selectors there, and then we can manipulate data with functions and functionality that we have in the platform. And finally, you can see at the end, we have filter condition. That lets you limit return rows, do things like grouping and things like that as well. So with that in mind, pretty much all of our use cases are driven from that VQL structure. You can kind of read what's on the screen here, but what drew me to Velociraptor was the customization. It's essentially like a big Swiss Army knife. When you're doing an IR, the available content in the platform is pretty good, and we cover most use cases, but the ability to quickly kind of write ad lib or to quickly roll out capability tactically, for me, was an absolute game changer. I could quickly write some content short term that I needed to collect something or get a piece of data for research or whatnot. Alternatively, if I wanted to, say, apply longer term, I could deploy a plugin as well and modify the platform. Finally, if you're really stretched, you can look at using some of our shell out plugins to just run third-party tools and things like that. So it's that expandability that's critical when you're doing an IR to just get the job done fast. Here's some links I recommend to everybody starting out. There, first of all, our project page at the top. Secondly is a document and training page that has things like videos, as well as like references for all of the functions, plugins, etc. And finally, you've got our Discord community, which has a really nice community of contributors, and that I would definitely recommend plugging into that and asking questions to learn. So the next kind of area I'd like to cover is some incident response needs. And here you can see is access to data. And this is a primary need of IR, where essentially you've got your traditional digital forensics and incident response data at the top, which is, say, volatile data, like in-memory artifacts, running processes, network connections, all of that stuff. The middle section, you've got kind of your static data. So think of that as like your logs on disk, your file system, your registry, event logs, that kind of stuff. So that's more your traditional disk forensics. And finally, at the bottom, you've got more your modern EDR focus, which for the most part is heavily process focused, but essentially it's that telemetry that gives you view on active threat. And all three of these are kind of critical to do effective IR nowadays on the endpoint. And this is how Velociraptor covers these use cases. Essentially, the access to data is driven by what we call accesses. And I'll use the static, the gray box, as an example here. Essentially, you have accesses, might be file to access the Windows API. You might have disk system. You might have registry to access the registry. NTFS to access raw disk system. And then for plugins, you might use those accesses to parse the event log or another forensic artifact. An interesting accessor that I'm going to cover today is zip, which essentially lets us see inside zip files. And I'm also going to show glob, which is kind of a plugin we use in a lot of artifacts that lets you do exactly like glob is in programming, search over the file system or registry to look for things of interest. On the right-hand side, we've got volatile, and I've listed a few of our plugins there. Probably this is a good one to point out, third-party integration, where if you don't have a particular plugin, you can just write third-party integration. I've put the example there as injection. We can also run Yara natively. So there's a lot of capability that we have here in memory. And finally, event telemetry. A lot of customers will use, say, a third party here like Sysmon or an EDR as kind of like a detection layer. And Velociraptor fits in very well in that use case where you might deploy your EDR because they've got really tight detection for the things you're interested in. And then you might use Velociraptor for more of those forensics or live response use cases. Velociraptor also does our own telemetry. If I have time, I'll show it today, but probably won't, where we can leverage things like ETW, WMI. We can also use like monitoring artifacts and monitor things like the event logs and that kind of stuff. So essentially, I'm trying to set the scene here that Velociraptor is this big Swiss Army knife of capability that gives you visibility into the things on an operating system that an incident response team would be interested in. I'd like to cover off our scenario overview for the demo. Essentially, I'm going to be showcasing an initial infection from a template injection use case. And this is a really interesting sample. The sample essentially doesn't have traditional execution that you'd be able to review with an EDR, in that it just drops a persistence mechanism. It drops a link file in a startup folder. The actual payload itself is kind of sideloaded by a signed binary, a custom encoded Cobalt Strike. And if you're interested in looking at the sample, I've added the hash there in the virus total section. I've also added my fake template with embedded like payloads and things in there. If you want to check it out, and there's some markers there that you can tell it's me to make it easy. The key indicators that we're going to use is the top right-hand side. So we're going to search and discover this particular threat out there. Okay, so the first component I'm going to show is the discovery or identification stage of our scenario. A Velociraptor has the concept of hunts, which is effectively running a VQL across groups of machines. In this case, I'm going to be targeting all machines, but you can, say, limit your hunts by pointing at, say, a group by label or by operating system. The first artifact I'm going to add to the hunt is a detection artifact for template injection. Template injection is interesting because instead of storing the malicious macro payload inside an Office document, an adversary will configure the document to kind of point externally for a second stage payload. This technique is a defense evasion technique to bypass maldoc scanning on delivery. It's also a similar technique to CVE 20214044, which instead of using VBA, it uses a different payload, but it has a similar style of configuration. So I've added it into this artifact. The artifact itself is laid out pretty easy to understand. We've got a search glob that's recursively searching the users folder looking for document files. We're then obtaining the path of all the document files, and then we're using the zip accessor to kind of look inside and look for those configuration files that we're interested in. After we have all of those configuration files, we're using the zip accessor again, and we're pulling out the configuration, the target that I was referencing before. We also pull out like enrichment and like timestamps, as well as hash sections, the document itself for presentation. But the whole idea is we're able to then detect those malicious configurations that template injection or that CVE uses. Similarly, I also want to add an artifact called Office Server Cache. And this was submitted by one of our Velociraptor users to our artifact exchange. This works kind of similarly in that it uses glob as the main finding mechanism, but it's using a registry glob here. And what it's doing is it's looking at an artifact that is generated when an Office document reaches out to an external server. There'll be a registry key that's generated, and it's a really handy artifact for kind of giving yourself validation to find out if there was like an opening and there was that attempted connection out. Finally, I'm going to search for the link file that was referenced. And this one definitely is an indicator of successful execution of the template injection. And this is dropped from the payload. You can see here we've got a glob that's looking for the link file that's generated, and then it's using what we call a binary parser to parse out the details of that link file. So once you select your artifacts, you see you've got configuration, and it's quite easy to add in changes or add in targeting. We can select to upload if you'd like to preserve a copy or maybe analyze it offline. But in this case, I'm just going to launch it. And when I hit play, it's only going to take a few moments to run. All of these are fairly lightweight detections. Interestingly, the template injection is using, as I mentioned, the zip accessor, so it can kind of see inside zip files. You can also run things like Yara using our zip accessor. It's worthy to note that if you were going to use Yara and just do a straight Yara scan, you may not have visibility inside zip files. So it might be a bit difficult depending on the tool set you're using. In this case, you can kind of see we have results here. So at the top, we've got a detection for our template injection, and you can see it looks like it's a resume in the downloads folder. We've got a section listing that's settings.xml.rel, so that is a template injection file. And we do have our domain that was an IOC along with the template file reference there. Other useful kind of forensic artifacts are the modification time of the section. So this is taken from the zip file, which is kind of interesting. And the last two hits are from CVE 2021-40-444. And you can see there's a slightly different reference file there because the target configuration there is in a bit of a different location. Also, the template target is slightly different. And in this one, we're actually keying on that MHTML string inside the target. You can see the second item we ran in our hunt. We do have a registry key that's named our domain. So we can confirm that, yes, the malicious VBA ran and it did reach out to the internet. And finally, we have found the link file. So the link file has been dropped, and you can see it's been parsed with relevant timestamps as well as payload. On each of the artifacts, we do have the fully qualified domain name of the machine that the hit was on. So the next stage is triage of our machine in scope, and we simply can search for it. And here we can do things like add labels. I've already added a couple to this machine. You can click on it and see additional metadata. Some people actually use this client metadata here for really advanced workflow, like case management and allocating analysts and things like that. But the first thing I'm going to show you is what we call the VFS view. And in the VFS view, you can see on the left-hand side, we list different accesses. So here we've got NTFS, which is essentially parsing the MFT. At the top, we have file, which is essentially using the Windows API to review the file system. And what I can do is drill down, and I can show you the items of interest. There's ecmd.exe, and this is one of the files that was dropped. And we can see that, yes, it is an MZ file. I've actually already uploaded these to the server just to save a little bit of time in the presentation. And here we have our Cobalt Strike stager, which is essentially an encoded in hex, and then it's loaded by that executable. And this is the kind of view that you get from other forensics tools, and enables you drilling into the file system or the registry in a similar way. So the other thing I wanted to show was the collections view. And what you can see is essentially all the VQL jobs that we've ran on the endpoint. And here you can see the hunt, for instance, and you can see the results, as well as the VFS browsing that we were just doing previously. And as I click on them, you can see that it's literally a row for each of the folders we're viewing or when we're looking at the file, etc. And this is a really good example to get your head around how VQL works, in that every function on the client and on the server is just a VQL query. And when you start to think that way, you start to understand how you can really leverage Velociraptor to do some amazing functionality. In this particular use case, the next step for me would be, say, a live response, like a triage of the machine. Now, a lot of customers, they would run maybe a live response collection and collect relevant artifacts. And in this case, we've got a cape, which is essentially a parody of Eric Zimmerman's cape files tool. And what cape files does is lets you collect those raw artifacts in a really easy to consume way. Now, in my use case, typically I just do preservation. So I've got a copy of event logs as soon as possible to the incident, so I can go back and take a look. But you can see here, we've got an easy way to select either artifact packs or individual artifacts that may be relevant. And I can just add them together and just add what I'm interested in. I can maybe target the VSS or target a different disk if I prefer. Some customers actually use a capability that we have in Velociraptor called offline collector, which lets you build kind of like a self-running binary that will automatically execute artifacts. And then you can give that binary to, say, an end user to run. And then it will generate that live response collection for you, which is a really powerful capability. Some customers even say add into that an artifact that will send the results to like a cloud share. And again, it's all fitting into the workflow that they decide to deploy with Velociraptor. For me, I run lots of live analysis. So in this particular use case, I might be interested in scoping to see if I can find any files were written around the time of the exploit or afterwards within the attacker activity. So I might want to look at the, say, MFT. But one capability I have that I want to show is leveraging the Velociraptor macro parser. Velociraptor has a plugin for VBA parsing. And you can see in this particular artifact, what I've done is implemented the OLE tools MacroRaptor capability in VQL. So what we do is we parse essentially the same as last time, a glob recursively looking in the users folders. And that's going to hit things like temporary internet files. What we do is once we parse all the documents that are associated there, I then run a regex over it and look for these parameters. What MacroRaptor actually does is macros will always obfuscate, bad guys will obfuscate and try to hide their malicious code. But there's some things in malicious macros that you can't hide, like auto exec, that has to be unobfuscated to actually execute. So that's kind of what we're looking for. And this tool is absolutely amazing as a first step to run over macros, and we can run that capability remotely. So I'm going to bounce through this and show you. And obviously you can change the search terms if you prefer. But when that runs, we should get results popping back again pretty quickly. And you can see straight away we found temporary internet files. You can say it's the same. You can see it's the same file name as our template that we discovered in the previous hunt. And then you've got a copy of the VBA code. I know that view isn't too good, but we can actually download a CSV, then copy paste it out. You can see we have malicious macro there. You can also see we're detecting on user forms, and those user forms actually have the payloads encoded in them. So this workflow typically might take a while. You need to look in the MFT, you need to then search temporary internet files, and you need to go back and make sure you've actually downloaded them and collect them again. But I'm able to pull this information back in a matter of seconds. And that's pretty amazing workflow. Okay, so next up, I want to triage the binary that was dropped. So I've written a little artifact that essentially extracts things like PE attributes and authenticode. It works by taking a glob target. And in this case, I'm globbing program data and all files located in there. This one is super fast. And when it returns results, you can see its output file information, system information timestamps. It's worth it to note we can add file name timestamps if we want to use our MFT parser and our NTFS artifacts. It also is included PE information. So you can kind of see here things like PDB, good for research information, but this particular binary is claiming to be an ESET command line tool. Imports, that DLL import does reference a .NET binary. There's no exports, but interestingly, authenticode. So the file itself is signed, but it is invalid. And this is a really good point to make with Velociraptor. Because we're on the endpoint, our authenticode parser will also look at things like catalog files and we'll be able to validate binaries really fast. I've recently written an artifact and some monitoring for the print nightmare vulnerability, where I was monitoring for a print creation event. And then I was using this kind of enrichment to look for untrusted binaries. And these are the kind of use cases that you can build out. There's lots of options for us. Okay, so one other thing I'd like to follow up in terms of this scenario, and that's a Cobalt Strike parser. Okay, so in terms of Cobalt Strike parser, the artifact itself is doing a lot of things. We're using a feature that we call binary parser, but before we do that, we're extracting the config out using Yara. Cobalt Strike is interesting in that typically the config is XORed, and it's either XORed by 69 for an older version 3 or 2E for the newer versions. I've also included the option here to brute force if anyone has maybe modified Cobalt Strike and decided to mess with it, so I'll select that. But what we do is once we have a hit for a configuration pattern, we'll then extract bytes, and then we will run our parser profile over the top of it. We'll also do things like detect, so you can copy paste some Yara in here that you'd like to run as a detection use case. In terms of selecting what we want to run the config over, we can either scan on disk and use the glob, or we can specify a process ID or a process name that we're going to run on. So I'll launch that, and it's actually pretty fast. Cobalt Strike itself isn't really anything special in terms of how it's configured, in that it's just a simple kind of an index type length and then value structure. And Velociraptor's binary parser is really simple in that it's kind of like volatility V-types, and it's designed essentially to overlay over the top and very simple to be very repeatable. And in this case, I've literally just copied all the other parsers out there and have enabled extracting the config really quickly. So what we're doing is we're essentially cutting out a step of triage here, where typically you might have, say, a detection via scanning memory via error, and then you need to dump the process and then analyze it. Here we can just run this content to extract the config straight away. And you can kind of see all of the configs in here, which is pretty awesome in terms of speed. I've also included the decoded data, so you can take that and run additional analysis on it if you need to. But I think this is a really handy capability and really showcases some really advanced functionality that Velociraptor can do. I think just to close up in terms of the demo part, it's probably worthy to touch on some of the other capability that Velociraptor has that might be useful. I haven't really had time to showcase like our event log stuff or any other content, but essentially because we've got access to data, we can do things like regex over or grep over event logs and have detection and scoping use cases there. What I would like to show is some of our Yara artifacts. So in terms of deploying Yara, I've got cross-platform Yarrow capability here that will hit Linux, Mac, or Windows using our glob function. And you can kind of see the description here. We select a Yarrow rule, either via URL or shorthand version, or just copy paste a Yarrow rule in, and then we can run a whole bunch of globs to hit. We've also got an NTFS version, which does the same thing, but searches with NTFS fields. And finally, we've got our process Yarrow, which by default will search for Cobalt Strike, but literally you can copy and paste any Yarrow rule in these rules and scan for the targets in scope. It's really handy, and it really helps with detection, and not only detection, but discovery and identification when you're doing an engagement. The wrap up for today is Velociraptor enables serious DFIR at scale. There's something for everyone. My advice is to work towards building your own workflow. Like I was touching on before, like what I see is typically people will start out doing like traditional live response. Then as they get more mature, they'll start to do more live analysis. They'll start to build out use cases with things like SOAR and automation and things like that. But just start playing with it. And you'll see like how easy it is to modify, and the modularization of it just makes it an amazing tool to work with. And most importantly, join the community, because the community is just really starting to take off now compared to even a year ago. Like we've got exponential amount of people coming into the platform, and a lot of that is just drawn by the word getting out for how awesome the tool is. Our goals are to essentially make Velociraptor the default DFIR tool, and not only endpoint forensics, but instant response, doing a bit of malware analysis. You can just run really awesome use cases using Velociraptor. Here's the links again that I posted before. I won't read them out. You can see them, but feel free to contact us. You've got myself and Mike, who currently are permanently working on the project. But also I added Wes in here because he's done some recent talks that have been absolutely amazing, talking about some workflow with Velociraptor. So he's worth following as well. But follow us on Discord and you'll get a lot of value. Thank you. That's it. Herding Velociraptors. So first of all, a little bit of an introduction. First of all, a little bit of an introduction.
To everybody on YouTube,
First of all, a little bit of an introduction.
Now.
Oh, we've got to mute that.
To everybody on YouTube, that concludes the online portion of day one for streaming. So we'll see you tomorrow back here, 9 a.m. Perth time. Okay, let's kill it. Kill that. Cut.
Inception dolls.
For everybody still physically here, we have one more talk. So Gareth, come on up.